Welcome back, everybody. In this section, we answer the question, what are the different types of volcanoes? And the three kinds we're going to talk about are cinder cone volcanoes, or sometimes ash cinder volcanoes. These are going to be relatively, steep things, not very far across. You notice the scale, 1.5 kilometers. That's really not too big for a volcano. We have composite volcanoes, otherwise known as stratovolcanoes, intermediate volcanoes. These are going to be a little bit wider, 15 kilometers here, sort of a moderate flank angle, and then we have our shield volcanoes. So up to 150 kilometers wide or more, very, very low flank angle, broad, shallow things shaped like a shield. And we're also going to talk about supervolcanoes, of course. So we'll start with the simplest type of volcano. You imagine, all right, before all of this stuff is built up, there's a crack in the ground and out comes something of an earth shard. So you have this mixture of lava, liquid rock, but also solid rock, the cinders coming out. And it spews straight up in the air, all the material comes right back down, it solidifies quickly, it cools, and what you essentially have is this building pile of rubble around the volcanic vent. Now, you might imagine, though, that instead of this runny, kind of thin lava coming out, you have something that is a little bit thicker, more sticky. And as a result, you build a much larger structure. It's going to be aerially much more extensive than the cinder cone volcano, something called a composite volcano. And when we think of volcanoes, places like Mount Rainier, Mount Fuji, even San Francisco peaks up at Flagstaff, this is what most people think of, are these. They're also called stratovolcanoes. You hear composite volcano, these are the same things. These commonly will have those pyroclastic flows as well as other things. Lahars are volcanic mud flows, lots of ash. These tend to explode very violently, possibly the most dangerous type, other than the supervolcanoes. So the internal structure on these, it alternates usually between lava, going to be formed as igneous rock. Here, dried lava flows, cooled lava flows, and these layers of ash or pyroclastic flows. And so it grows outward into this sort of classic mountain shape. Our final type of volcano here is the shield volcano. So you might imagine something like the island of Hawaii. You may have heard that it is actually one big volcano, and that is correct. You have the most free-flowing lava. It doesn't build up any kind of structure at all. It spreads out aerially in all direction and slowly builds up this kind of dome shape, this mound. It's called a shield volcano because if you look at it from the side, it looks like a shield. These tend to be very, very gentle in terms of how they erupt. That's why people can live on the islands of Hawaii. Usually basaltic lava flow with these. It slowly builds up hundreds of these little layers. So if we look at Mauna Loa in Hawaii, you see this broad dome shape, these layers built up, very, very gentle slopes, low sort of angle here. This is a shield volcano. And since I forgot to show you guys a picture of one earlier, this is a cinder cone volcano here. You notice you have a relatively steep angle. It's really not that large, though it's kind of hard to tell in a picture like this. And you have this pronounced crater up here at the summit. And last, but certainly not least, we have our supervolcanoes. Now, these tend to be extremely rare. You got maybe 7 of them in the entire world. 3 of them are here in the United States, including everybody's favorite of Yellowstone. Now, to be a supervolcano, you have to pass the bar here for 1,000 cubic kilometers of material spud into the air if you were to erupt. For reference, Mount St. Helens is about 0.29 cubic miles. It's about 0.1% as big as something has to be a supervolcano. So 1,000 times worse than that. You have a huge magma chamber, unimaginably large. Even the kind of ridiculous picture here does not do it justice. It erupts all in one big blast and ruins all life on Earth, maybe, and tends to be filled with rhyolitic magma. Now, the largest supervolcano here in North America sits below Yellowstone in Wyoming. This is above a hot spot. We have this pillar of hot material coming up from the core of the Earth all the way to the surface. And this one in particular tends to erupt about every 600 to 700,000 years. So we had one 2.1 million, one at 1.3, and then one that was about 600 to 700,000 years ago, which means... So then, if I were to ask you why certain volcanoes are one type in one area and other volcanoes are a different type, you would tell me, well, it all depends on the plate boundary, it depends on the chemical composition of the magmas involved, and it all depends on the viscosity of the magma. These 3 key factors are what determine the type of volcano, the structure, and the type of eruptions that you get. For the final section, we ask the question, are there volcanoes in Arizona, and if so, what kind and how did they get here?